These are the notes for Chapter 5, Section 4, Solving Radical Equations. So in our own words, the meaning of a radical function is just that x is under the square root, or any root, okay? So some examples might be y equals square root of x, which is the same thing as saying x to the 1/2. So that is still a radical equation because they mean the exact same thing. You might have y equals the 3rd root of x, which is also the same thing as saying x to the 1/3 power. And like y to the 4th root of x, and so forth, okay? Same thing as saying x to the 1/4 power. Okay? Now, an extraneous solution. This first part of the word kind of gives it away for me. It's an extra solution. It's a solution that when you calculate or algebraically solve the equation, you get 1 or 2 answers. And if you plug it back in, the answer doesn't actually work. So these are solutions that do not actually work. Okay? Now, we'll kind of cover those more on day 2 or in the second video. Solving radical equations. So there's steps to follow. You isolate the radical on one side of the equation, if necessary. Sometimes that's already done. Step 2 is you raise each side of the equation to the same exponent to eliminate the radical. So if it's a square root, then we're going to square both sides. If it's a cube root, then we're going to cube both sides. Okay, that gets rid of that root or the radical. So solving equations, after you solve them, you use the techniques we've learned before, which, moving numbers to both sides, adding or subtracting to both sides, all of that, those algebraic steps that we've learned. And then you have to check your solution, okay? You have learned different techniques for checking your solution, okay? We've learned, so one way to do it is to graph it on your calculator. Okay, the x-intercepts should match your solution. All right, so that's one way to check. So if you get one answer when you solve it, and you graph it, and that is where it crosses the x-axis, that was correct. If you get an answer and the graph doesn't actually cross the x-axis at all, that means that's one of those extraneous solutions. If you get 2 answers and one of them shows up on the graph as crossing the x-axis there, well, then the other one is extraneous, and that's how you can use graphing. The other way that we learned, or you have done in the past, is you just plug answers into the equation to check. If it comes out as a true statement, like 10 equals 10, then that was correct, okay? 0 equals 0 or whatever. If you get something false, like 0 equals 1, well, that's not true. So that would be an extraneous solution if that is the case. So let's solve a couple of these today, or a few, okay? So number 1, we want to solve this equation. So step 1 said isolate the radical on one side. Well, it is. The radical is all over here. I have just a constant over there. It doesn't really matter what's on the right side as long as that radical is by itself on the left side. And then to get rid of it, it's a square root. So to get rid of a square root, you square it. Well, if I square that side, I have to square this side. Let me get my thickness a little smaller here, sorry. And so that means this becomes 1 minus x, the square root and the squared canceled out, and I have 7 squared, which is 49. Okay, and then we just go about solving for x the way we would algebraically. So here we got to subtract the 1. So I get negative x equals 48. Still haven't finished solving for x. I have to get rid of that negative out front, so I'm going to do that by dividing by negative 1. And I get x is a negative 48. Now, before I box it as that being my answer, I need to check and make sure that works. So you can graph it on your calculator. The only problem is you have to set this equal to 0. So you'd have to subtract that 7 to the left side to plug that in your calculator. Otherwise, just check it by plugging it into the original equation. So I would have the square root of 1 minus a negative 48 equals 7. Okay, minus a negative makes it plus, so it's plus 49. I'm sorry, I just wrote 49. It's 48 equals 7. So square root of 49 equals 7, and we do know that is true. Square root of 49 is 7. So this worked out. This is my official answer. All right, oops, sorry about that. Scooch over to number 2. Okay, again, the radical is isolated there on the left side, so step 1's already done. And now I need to raise each side to that exponent that matches the root. So this is a cube root, so I need to cube both sides. So I'm going to power of 3, power of 3. Okay, so that leaves 5x plus 1 on this side. Because remember, whenever we take it to a root to a power, they cancel each other. All right. And then if I take a negative 4 and I cube it, I get negative 64. And then I go about doing my multi-step equations here, minus 1 to both sides, solving for x. So I get 5x equals negative 65. I divide by 5. X is going to equal a negative 13. And again, before I say, okay, that's my answer, I need to make sure that it actually works. So I'm going to check it. So the original equation was 3 square root of 5 times x, and we're saying x is negative 13 plus 1, and that needs to equal a negative 4. All right, so the third root, let's see, 5 times negative 13 is negative 65 plus 1. Let's see if this still works. So square root, I get a negative 64. And that is a negative 4. So this did work out. So I can now box this and say it is my answer. Okay, number 3. No, it skips 3. Sorry, my numbering is way off. Number 4 here. Now, we do have to do step 1 this time. It says isolate the radical on each side. The radical is this, but I have this extra 2 out front. I have to get rid of that. Now it's 2 times the cube root, so we're going to divide by 2, since that is the opposite of multiplication. Okay. These are the, whoa, I went a little crazy with that. The 2's are now canceled on this side, and I have the third root of 13x minus 5, and then I had 10 divided by 2 is 5. Okay, so now step 1 is done. We isolated the variable. Step 2 says raise it to the power, same exponent as the radical. So this radical is the cube root, so I need to take it to the third power. Well, if I do it to that side, I have to also do it to this side. Okay, so that leaves me then with 13x minus 5. It's going to equal 125. And then we do our multi-step equations here. So plus 5. 13x is going to equal 130. Divide by 13. I get x is 10. And let's check and see if that works out. So the original equation was 2 times the cube root of 13 times x, which we said was 10, minus 5, and that's all under the root, and that needs to equal 10. Okay, so let's do some simplifying here. I have 13 times 10 is 130. Okay, let's keep simplifying inside that radical. So I get 125. Oh, whoops. I just realized. I'm sorry. I wrote a 3 there. That's supposed to be a 2. Now I get 2, and the cube root of 125 is 5. So now I have 2 times 5 instead of 2 times the cube root of 125. 2 times 5 is 10. That worked out. And remember, you can also check it using your calculator. This is the only examples I'm going to do for this video. There will be a second video for 5.4, and it will include problems that there are extra solutions. So do get in the habit of doing the checking.